Well, good afternoon. Good to see you all here. I actually started this work because I was thinking about writing yet another security book, but one that would be really basic and just give people the very most basic stuff that I thought they needed to know, something that a sophomore in college could appreciate. And along the way, I discovered that people really didn't like usernames and passwords because we have to have a username and password for banking, travel, shopping, chatbots, work, maybe church. And every organization has their own standards for how you create a username and how you must create your password with a certain amount of a mixture of characters. Passwords are secrets. Usernames are not. That's the basic thing I want you to get out of this whole talk, but hopefully along the way it'll be more fun than just that one sentence. Usernames, when we're using a Linux system or a Windows system, they actually map to an internal identifier. In Unix or Linux, it's a very small integer, like 1,000, which is the default first one. In Windows NT, or we just call it Windows these days, you get a security identifier. And actually, when you log into Windows, you actually get a set, an access token that's full of security identifiers. Anybody recognize that particular security identifier? That's for the local, it's the local security administrator account. So that's like root in a Linux system. Now, the other way that usernames are used is for account information and services. So say you're going to an online store, you give it a username that identifies your account information, which will have things like your shipping address and your credit card information. Now, UIDs and security identifiers are actually part of system security. They represent the ownership of files and processes on a Linux and a Windows system. And this is really a very important aspect of security because it protects you from other users on the machine, if there are other users, and it protects the operating system from you as well, to some extent. They may grant you elevated privileges. If you happen to be a member of that particular security ID, if that's a group of yours in the Windows system, you have root access on the Windows machine. When used for process ownership, hardware actually supports, provides support for virtual memory, which increases security. Now, if we go far enough back in time, we didn't have virtual memory at all. Virtual memory shows up in the Intel 8286 in 1982, but the computers most people, operating systems most people were using back then didn't use it. For services, usernames map to your account information. Now let's think for a couple of minutes about identity. If you live in a small town, well, how many of us live in small towns today? But say you, there we have, I see one hand go up. So say you live in the Maritimes in Canada, where there are a lot of small towns. There are some small towns, like I remember Evergreen in Washington. That was really small, okay? If you're in a small town, probably everybody knows everybody else, or at least you recognize them. Today, we live in cities. I live in a modest-sized town that can have up to 10,000 people in it. So there's no way my banker is going to recognize me, unless the teller, for example, happens to be my neighbor. But other than that, there's no way to establish my identity without some form of proof. Now, our common way of providing proof these days are things like a debit card. So use a debit card when you visit a bank or use an ATM. You're going to authenticate, right, your debit card, weak authentication, but still, because you possess it and you know a PIN. Your driver's license, you need that to enter a airport's boarding area in the United States. Of course, if you're not from the United States, you're using your passport. These are forms of identification. And just the fact that you possess these is a way of proving your identity. Of course, with your driver's license, your passport, there's a bit more there about what do you look like. Now, note, both of these will work with computers. Seems like everything will work with computers these days. Your debit card has a chip in it, an RFID chip, and your driver's license, if you're a US citizen, actually has a special barcode on the back that's machine readable. Now, neither bank cards or driver's licenses appear to have usernames. What they have are numbers instead. How many people here have memorized your bank account number? Yeah, okay. Yeah, I see there's some geeks. I know what my checking account number is. How about your driver's license number? Oh, even more, okay. So some of us do, but frankly, if you actually went, a policeman stopped you and you said, oh, my driver's license number is FC, 80179 BC, and he would go, no, I want to see the card. Okay, so it doesn't do you much good there. When we use online services, we typically have usernames. And here's some example usernames, like my email address, bdobbs333@yahoo.com, or just bdobbs for a username on a computer. Windows has this interesting thing where you could have a domain name / and a username. I didn't know that until I was looking for this course. Now, usernames really took off in computers. Well, they didn't really take off. They slowly started to be used starting in 1961 with the compatible time-sharing system, CTSS, at MIT in 1961. A more popular time-sharing system was Dartmouth time-sharing system in 1963. Remember, Dartmouth also gave us BASIC. Multics was born in 1965, but it's still being used into the 80s. Honeywell, which acquired GE and IBM time-sharing system. So that's when people first had usernames, but before they had usernames, all they had were account numbers. Now, this is a computer similar to the one I used when I was in college, except I couldn't see this because all I could see was the desk where I handed in my punch card deck. The computer, by the way, is to the right of that little group of people, and in front of the woman, that's the punch card reader. So that table with the chair in front of it is actually full of hand-wired components. That was the state of the art. And here's how we interacted with the computer. You had a deck of cards, and the top of that deck of cards had your account information. Notice it says, well, I'm sure you can't read it, but at the bottom of the slide it says Arnold, CM 6920, 7255, 2 and 2000. What that is Arnold that's his first name. So when he goes to get his output from running the program, that will be on the output. It's not his username. His username is actually that number that follows that, and that's his account name. So that account name is used for accounting purposes, literally. If you don't have an account information for using the computer, they're not going to let you use the computer because computer time is extremely expensive. And I'll give you an example of that in a few minutes. Also, that account information that we see on the punch card assigns privileges. For example, can Arnold use tape drives? Okay. The thing about this punch card is there's no authentication. So if you're somebody and you want to borrow somebody else's account, all you need is a copy of that top card. And of course, that the person who accepts the stack of cards from you doesn't recognize that you're not Arnold. That small town effect. Now, mainframe computers are very expensive. When you look at what a computer like this could do, how much memory it had, it's appalling. I mean, we're talking about machines that might have 48K words of magnetic core. And you might have a disk pack in the later versions of like the IBM 7094, you actually could have a disk pack where you'd have something you put inside of what looked like a washing machine, and it would give you 10 megabytes of storage. There was no support for multiple users. So mini computers changed a lot of this. They started being developed in the late 60s. Digital equipment might still be a name for some of you. Less capacity for moving data and storing data, but only a 1/20th as expensive as a mainframe. And what changed a lot of things was Ken Thompson creating an operating system called UNIX. Here's a picture of a PDP-7, similar to what Thompson would have been using at Bell Labs. Notice that off to the right, there's a teletype Model 37 without a paper tape reader. And you see where the chair is, that's the operator's console. And look above the chair, you can see there's a circle. That circle is actually an oscilloscope that you can use the computer to draw on. And one of the things Thompson had done is created a game you could play with these mini computers where it was like space, not Space Invaders, but where you chase each other around in spaceships. And the reason that didn't work so well on the mainframe is, one, the mainframe didn't have that oscilloscope, and playing a space travel game that Thompson had written on the mainframe would cost about $75 per session, which in today's dollars would be almost $300. So $300 an hour for playing a game. Thompson wanted to be able to use the computers that were there. That PDP-7 wasn't terribly useful. It did have a 5 megabyte hard drive in it, but nobody had tested it. So he wrote software to test that 5 megabyte hard drive. And once he'd written that software, he realized that he was not that far away from having an operating system. Now this machine has 36K 18-bit words in it. That was the total memory. Most people here can relate to that, but another way of thinking of it, it would be 36 pages of typed text. That's it. His wife and family were going to visit family in California. So he realized he had evenings off for the next 3 weeks, and he wrote an operating system. I always think that's very impressive that he actually did this in 3 weeks. It supported 2 users. So with this new operating system, users need to log in, providing a username and password. And like I said earlier, it identifies the user's account and privileges. There is a special account called root. I'm not going to talk much about that. The password authenticates the person logging in that they own that account. Username was mapped to a small integer, and in those days, it was just 1 byte. And usernames were short, like DMR. I think part of that was having to use that teletype 37. So this is largely where we came up with usernames, because the thing about Unix is, unlike other things before it, it ran on relatively cheap hardware. Lots of people had this. I think by USENIX USENIX had a meeting in San Antonio in 1982, and in somebody wrote up a summary of that, and they said that at that point in time there were 1,200 Unix licenses. That was it. But when you compare that to the number of, say, GE mainframe systems, I worked as an intern for GE one summer, and I was in charge of distributing patches and updates. And they had 14 GE 245. Those are the types of systems that was not running Multics in 1970. So you compare that with 1,200 Unix licenses, that's quite a bit. Now, as we move forward in time, let's jump up to the 90s. Now we have the internet. Things are changing. People have a way of not just working with their own machine, which is what you had to do in the 80s, unless you happened to be in a university, but you could use other people's machines. And hackers love to use other people's machines. They also like to brag, and one of the ways they would brag is they created special usernames for themselves, which we called handles. A handle is a way of isolating the real person, the identity of the hacker, so the vendors and their lawyers, who often responded very harshly when their security weaknesses were publicized. You know, I've heard some interesting stories here. I won't go into it though. Now, moving forward a bit further, by the late 90s, we're starting to see online services, online stores. We have Yahoo, we have Microsoft Mail, eventually Gmail, and these have millions of users. So if you have millions of users, and each user needs to have a username, what do you think happens when you try to use, say, my name, Rik, as a username? If somebody else has already used that. Okay, so that's why you'll see things like bdobbs3333 or honeysuckle lover as usernames, because people are trying to pick names that have no collisions. Now, when you log into an internet service like a web or mail server, it's like logging into the mainframe computer. You're not actually owning a process. The processes are owned by internal server software. Say if you're running Apache or Nginx, it's running as www data. Okay, it's not running as Rik or bdobbs. This is that your username is only used for accounting and identifying your account information. That's it. So things like your credit card number, the addresses you've used, your buying history, and so on. Online stores work the same way. Your username identifies your account. Now, one thing about internet servers, these are great places to harvest, if you're a hacker, password information. It makes them very popular. And this is why you never want to use the same password on multiple servers. Oops, and I went the wrong direction. So as a summary, usernames are barely security sensitive, used to identify accounts. Think of a username as like a driver's license. It's a means of identification. In Linux and Windows, they're also used as part of the security system. They own processes, they're file owners. You have lots of usernames and they are not secrets. Passwords authenticate usernames. Passwords are old tech. Someone from Computer World Europe asked me in 1999 if I thought usernames would still be used much longer. And I said, oh, maybe 5 years. Here we are, 26 years later, we're still using passwords. You really want to be using multi-factor authentication whenever possible. And that's it. Oops, and I went backwards again, sorry. There we go. So any questions?